Hello, everyone. Today we will talk about what we call it as the triple integral. This is a generalization from the previous meeting, which is actually double integral. Okay, so we will see it now. So consider a box shape. Okay, this is let's say a B. Okay? This is in a 3D. Okay, this is X, Y, and Z, and this is a box B. And then inside of the box itself, there is a smaller box here, which is it has dimension x, y, z also, exactly the same. If we zoom in, okay, this is a box, what we call it as a BK. Okay, this is a smaller box inside this box B. It has the width itself is a delta x, delta x, and then delta y is the length itself, and then the height itself is delta zk. Okay, so this smaller box is actually we call it as a bk. So the big box B, we first we make a partition into smaller boxes from B1 until Bn. Okay, and then we define what we call it. This is the largest diagonal, which is actually the norm of delta. This is a, let's say this is a notation that denote the longest diagonal in the decay. Okay, and then if we take let's say average value of xk, yk, and zk, which is actually in the box bk. This is to represent the position, let's say, the position of the bk, right? And then we take the Riemann sum, just as in the double integral. Okay, now we take the Riemann sum, but now you can see that the f here is actually a three function of three variables. Okay, f is executed. Executed at point xk, yk, then zk. Okay, and then there's a delta pk, what we stand for the volume of this smaller box bk. Okay, what you can see is we know if you remember the volume of the bk, this is a box, is actually box. Okay, the width times the length, and then the times the height itself. Put the let's point it, delta y, delta x times delta x times delta zk. Okay, this one is the volume of this box bk, let's say. And then just analogous with the previous in the double integral, if we take this the dimensions of the boxes become very small, or the diagonal of the small bk becomes very small, goes to zero, then we get the limits. Okay, meaning that we take actually the limit of the Riemann sum. What is the Riemann sum then? So this one, we take the limits from this delta. Okay, the norm of the delta. Delta is actually the longest diagonal of the bk, which is actually the size of the box itself. Then we get, if the limit exists, let's say this is a w, and w is defined as a function of x, y, z is integrable, Riemann integrable. In the box B, we can write it down as this one. Okay. Then we define what we call it as the triple three-fold integral. Okay. Then remember, in the twofold integral, we have this one is the area, but now in the 3D and the threefold integral, we have this one is actually volume instead of area. Okay, this is some more explanations. So what is delta V? Delta V stands for a volume. Okay, the volume of the BK, the box, the smaller box, which is actually the length, the width, and then the height itself. Okay, which is and then we multiply three of this, then we have volume. Okay, we have a dV. So that the integral and the threefold integral, then we define it something like this one. So we break it down, the dV to become dx, dy, and dz. Okay, for the example, we will try to do it on the canvas. Okay, we'll try to do it on the canvas for the integral. Okay, let's say we go to the simple example. Okay, so this is our example. Calculate the threefold integral, which is actually threefold integral x squared y z dv, and then it is defined over a box B. Okay, with B is defined as this is x y z L. This is with some conditions. The x itself is defined from 1 until 2. Okay, and then y itself is from 0 until 1, and then I will put it here. Okay, and then the z itself is defined. Remember, this is a box. Okay, this is until 1, 2. Okay, by using this, we know that this is actually box. Okay, this is a box, and then we just simply calculate it by using. Okay, now we will try to do it here. First of all, we write again the definitions of the integral in the, this is B and this is a volume. Okay, but now I break it down into dx, dy, dz. Okay, so I rewrite again the function itself, x squared y z, and then this is the dx. Now I do randomly, let's say from x, dx, dy, and dc. Okay, because this is a simple box, simple domains. Okay, and then x itself is from this one. Okay, this is from 1 until 2, and then the y itself is from 0 until 1, 0 until 1, and then the z itself is from the z from 1 until 2. Okay, now I will try to calculate it one by one. Okay, first of all, I would rewrite again the boundary in the y and z. 0, 1, 1, 2. Okay. Now I integrate this function with respect to x. Okay, remember, if we integrate with respect to x, other variables than x, we consider it as constants. Okay, in this case, which is y and z are considered to be constants. I just simply write it down here, y and z, and then times, and then now I integrate the x squared. Okay, it's become x to the power of 3 divided by 3. Okay, and then we take the boundary, which is actually 1 until 2. Okay, and then I will write the dy dz. Okay, I concentrate on this one. So this is 1, 2, this is 0, 1, and then I will calculate it here. First of all, I write the constant here, and then this is over 3. This one I put the x to the, and then I put the 2 here, 2 to the power of 3, which is actually 8, and then minus 1. Okay, so it's 7. Okay, so this one is actually 7. Okay, and then now this is a dy and dz. Okay, I think it is still correct. So I put it here. Write again. So this is a 7 over 3 yz. Okay, then what do we have? So 0, 1, 1, 2, and this is dy dz. Now I will try to calculate it with respect to y, which is actually the z is considered to be constant. Now I will try to do it here. 1 over 2, 7 over 3, and then z is considered to be constant. I'll write it first, and then I integrate with respect to y, and then it's become y squared over 2. Okay. Now I put the boundary. Y is so from 0 until 1, and then this is okay. So what do we have? I have 7 over 6. Okay, 3 times 2 is 6, and then this is a z, and then the y itself is from 1 square minus 0. Okay, this is this one. Okay, and then I integrate with respect to the z boundary. Okay, this is 7 over 6. Okay, this is z. I directly integrate it first, then z over 2 over 2, z square over 2, I mean, and then the z boundary is from 1 until 2. Okay, hopefully it is correct. Now what do we have? 7 over 12, and then 2 square, which is actually 4, 1 square. Then what do we have? We have 7 over 12. This is 28 divided by 12. Okay, or if I divide by 4, which is actually 7 divided by 4, 3. I think, am I making mistakes somewhere? Okay, that's it, I guess. So let me just try to compare it with the slides. So, am I doing correct or not? Okay, seemingly I made some mistakes here. So I made my mistake here. This one is actually 3. 7 times 3, which is actually 21. And then I divide by 4 by 3. I divide by 3, resulting 7.4. Okay, so this is the result. Okay. So what you can see, how we can calculate it first, and then what you need to remember, if you integrate respect to a variable, other variables are considered to be constant. Okay, that's it. Now we continue with the material. So this is what we have just done on the whiteboard, resulting 7 over 4. Okay. But now, how if we integrate, so integrate a threefold integrate, but instead of in a box, okay? So this one we integrate with on a arbitrary domain. Okay, let's say the domain itself is different in the boundary of the z itself, which is actually bounded from uh, pi one, psi one until psi two. Okay, and then the x itself is fixed. X is fixed from A to B, but the y itself is defined from pi 1 until pi 2. Okay, remember the domain of x is fixed. The boundary for the x is fixed from A to B, but the boundary for the y is different from pi 1 until pi 2, and then the boundary for the z itself is from psi 1 until psi 2. Okay, so if we consider S is actually some set, simple sets of Z, then in which S is the bounded are bounded by psi 1 and psi 2. So this plane XOY, okay, O is stands for origin, XOY, okay, it's considered as a, let's say, type 1, what we discussed in the previous two meetings, okay? And then we can write down the integral, the threefold integral, as the following expression, okay? First, we integrate with respect to z first, okay? Because this one is depending on the x and y functions, okay? And then we follow the integration with respect to y first, and then because this the boundary of y is depending on the x, okay, pi 1 and pi 2, and then the final one, which is actually where it has the fixed boundary, which is actually z x in this case. Okay, so if fx y fx y z is 1, then this one, okay, the expression of the threefold integral, it is actually volume. This one is actually volume of S, okay? Solid. So for the example, we will try to do it on the whiteboard as usual. We will try to do it on a whiteboard again. Is this example number 2, let's say. Example 2, okay? So this is, I will try to write it down. So this 2xy, 2xyz, and then it's bounded by, and then dz, dy, dx, okay? Boundary for the z itself is from 0 until 2 minus a half x squared, okay? Boundary for the y itself is from 0 until x, and then the x itself is from 0 until 2. Okay, let's just try to do it now. Okay, now we will try to consider this first. Okay. We integrate with respect to z first. Okay, what do we have? We this is a constant, so I write the constant first, and then times the z square over 2. I integrate with respect to the z, and then this is vanish. Okay, and then I put in the boundary itself. The boundary is from So the z is from 0 until 2 minus a half x squared. Okay, and then these are the boundary, and this is and then we integrate with respect to the x to the y, sorry, and then x. Okay. Now, what do we have? I just simply plug in this expression. So I write it down here, x, y, and then the z itself, I simply integrate, plug in, okay? Substitute this function. 2 minus half of x squared, and this is the square, okay? And then z is 0. I do not put it in because this is to be 0. Then dy, and then the boundary of y is from this one, 0 until x, and then dx, 0 until 2. Okay. So I break it down, break down this function, the square here. I will break it down. 0 until x, and then we have xy. This one is become 4. Okay, this is 2 x squared, and then plus 1 over 4 x to the power of 4. Okay, I guess that's correct. Okay, this is the dy dx. Okay, now I will integrate with respect to the y itself. Okay, we have this one. This is the y. Okay, I will just simply 0 until 2, and then x. I will write down everything in x first. 2x squared plus 1 4 x to the power of 4, 4, and then y squared x, the y itself. I integrate the y to be this one. Okay, and then the boundary of y is from 0 until y is x, and then this is the x. Okay, so what do we have? We'll put it here like this. I just simply plug in the y to the x. Okay, x, and then this is 4, 2x squared plus 1 4 x to the power of 4, and this one I replace it by x. Okay, what do we have? We have x squared, then I have x to the power of 3. Okay, divided by 2. That's it. And then 0 until 2. This is the x. The y is 0, is simply 0. Okay. Okay. Well, I will try to break it down here. We have 2x to the power of 3 minus vanish, 2 vanish, which is actually x to the power of 5 and 6. Okay. Sorry, 2x to the power of 5, yes, and then plus 1 8. Okay, x to the power of 7. Yeah, that's correct. 0 until 2 dx. Now I integrate it to x to the power of 4 divided by 4 minus x to the power of 6 divided by 6 plus 1 8 x to the power of 7 8 x to the power of 8 divided by 8, and then the boundary is from this is 0, x from 0 until x to x. Okay, and then I will first delete it, this is 2, this is 16. Okay, Okay, what do we have? Put it here. Uh, this is a half. Okay, x to the power of 4, 2 to the power of 4, divided minus 2 to the power of 6 divided by 6 plus 1. Sorry, this is 64. Okay, this is 64. 64. 1 over 64. 8 is a 2 over 8. Okay, so what do we have? We have 8 here. Okay, minus this is 64 divided by 6, and then I divided by 2 again. So 2, this is 3. Okay, and then plus this is 2 to the power of 5. That's what this is 2 over 8. That's 6. Yeah. Yeah, something like this. 6. Yeah. So in conclusion, this one is 2 over 2. Okay, we have 8 minus 32 over 3 plus 4. Okay, if you write it down everything, then we have 4 over 3. Okay, so that's all. So this is the answer of our problem. So there is a relatively simple, okay, straightforward. So we just simply taking the rule. If you integrate with respect to other variable, then that other variable we consider it as constant. Okay, we just simply following the rule of the integrations. Then we come up with this answer. Okay, thank you very much for your attention. So this is our last material for the calculus 2. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.